Hi, this instructional video is about graphing exponential growth function. You see, in the past, we had a function such as linear, where on a coordinate plane, we had a line go through the x and the y intercepts. And that was simple enough. Then we ended up doing some quadratic functions, where on a coordinate plane, we had some sort of a parabola, either open up or open down. Okay, and where it had two different roots, or the x-intercepts. And then we also talked about cubic function, where at most it can actually have 3 roots. And also we talked about a maximum and a minimum, if it actually existed. And then we also talked about, well, that was a cubic. And then we also talked about polynomial functions, where depending on the degree of exponent, for example, if it was to the 4th power, we may even have up to 4 roots. Yeah, but you see, in real life, functions don't always work like that. For example, human population. As time goes by, it gets bigger and bigger. Or maybe the temperature, as you go down to the below the surface of the earth, it may get hotter and hotter. So you see, in this case, if as x approaches positive infinity, meaning away from the origin, the f of x, or the y, also approaches infinity. On the other hand, as x approaches negative infinity, meaning away from the origin to the left, if you look at this line going to the left, the f of x, or the y, gets closer and closer to 0, but never actually becomes a 0, and this characteristic is called an asymptote. And so, seeing these characteristics, this exponential function, we're going to graph. And to do that, we're going to use the exponential growth function given as y is equal to a times b to the x power, where an a can be greater than or less than 0 sometimes, and b is greater than 1 and is known to have a exponential growth. So let me show you how this works. In order to graph, we need to have at least 2 points on a coordinate plane to give us an idea. So we're going to let x equal 0, just like the good old days. So here's the x, and when you substitute that x with a 0, any number raised to a 0 exponent, the entire thing becomes a 1. So this function, y is equal to negative 2/3 times 3 to the 0 power, is actually saying times the 1. So it's negative 2/3. So here's the y value. And then what if I substitute the x with the 1? Well, 3 raised to a first power is just simply 3. So if I substitute that into the function, y is equal to negative 2/3 times 3, 3 is reduced to a 1, or y is equal to negative 2. So here's the x and y for the second point. So now we could get an idea what this looks like. If x is 0, y is negative 2/3. So here's 1. Then 2/3 must be approximately here somewhere. And if x is 1, then y is negative 2. 1, 2. So it's over here somewhere. So if I follow that characteristics of an asymptotal line, what you get is actually a line that's decreasing as x approaches infinity. There it is. And the asymptote is when y is equal to 0. It's getting closer and closer to a 0, but never quite getting there. And that's how you graph this exponential growth function. So now let's have you try this guy. Okay, so we have our a and the b with an exponent x. So we need to find the two coordinate points to give us an idea. So you let x equal 0 first. And in this case, if you let x equal 0, anything raised to a 0 exponent is 1. So it's like saying y is equal to 8 times 1, which is simply 8. So there's our first coordinate. And how about if we let x equal 1? Then 2 to the first power is simply 2. So y is equal to 8 times 2, which is a huge number, but there it is. So if x is 2, y is 16. So now we could plot those points. Let's make it a little, give more space on the y-axis, because if x is 0, y is 8. So here's our first coordinate point, 0 and 8. And if x is 2, let's say somewhere over here is 2, then y is 16th, way up here. And the asymptote, again, is when y is equal to 0. It will get closer and closer to 0, but it will never get there. So it will look something like this. There you have it. So last time we talked about exponential growth function as being written as y is equal to a times b to the x power. But sometimes they do change positions. So now we have a thing called general exponential function, okay, which is given as y is equal to a times b raised to a x minus h plus decay, where the inverse of the h indicates the horizontal movement, horizontal shift, okay, and decay as given indicates the vertical. So what we're going to do is we're going to first graph the exponential growth function as y is equal to a times b x. And can you see that it's right over here? Y is equal to 4 times the base b, raised to an x power. And we're going to graph that first. Okay? So to find that, we're going to let x equal 0. So if the x is 0, this entire term is simply 1. So y becomes 4 times 1, or simply 4. Okay? And if I let x equal 1, 2 to the first power is just 2 times 4 is 8. Check this one out. Let's do this one. How about if I let x equal negative 1? Yeah, the exponent of negative 1. That means this will be written as y is equal to 4 over 2, wouldn't it? Okay, because the exponent now becomes positive as it comes down. So that reduces to simply 2. So now we even have 3 points to give us an idea what it looks like initially, that is. Because they will change positions, okay? So the first coordinate is 0 and 4. So 0 and 4. And the next coordinate is 1 and 8. So here's, if that's 4, here's 1 and 8. 1 and 8. And the third one, just to give it a better view, negative 1, then I'll give us 2. There it is. Okay? And given this exponential growth function, the asymptote is going to be when y is equal to 0. So it's going to look something like this. Whee! And it gets closer and closer to the 0, but never ever touching it. Okay? And that is the y is equal to 4 times 2 to its x power. However, now there's been a shift. There's a horizontal shift and a vertical shift. So we have to note that. So inverse of the h, even though it's written as minus 3, inverse is plus 3. So that means wherever this was, we have to go 1, 2, 3. And up 1, 1. Okay? So that way and that way. And here's our new coordinate. So this one also same thing. 1, 2, 3, and 1. And same over here. 1, 2, 3, and 1. And what happens is then the vertical shift actually becomes the new asymptote. So the line gets closer and closer to a 1, but never actually becomes the 1. Okay? So let's draw a dotted line to show that's the new asymptote. And it will look something like this. I missed it. But you got the idea. And this new line represents the general exponential function of y is equal to 4 times 2 raised to x minus 3. Let me move this mama gavel and the baby gavel. So you could try this guy. Okay. So you said, first thing I want to do is use the exponential growth function, the basic one. So y is equal to negative 3 times 6 raised to just the x without the shift. Okay, so we're going to graph that first to give us the initial position, like over here. So how that works is, we're going to find out where the coordinates are by letting x equal 0. So if x is 0, 6 raised to a 0 is 1, times negative 3 is negative 3. Yeah, and if I let x equal 1, that 6 to the first power is just 6, times negative 3 is negative, well, here, 1, negative 18. Whew, that's huge, isn't it? So let's give it a negative value and see what happens. If I put a negative 1, so we have an exponent of negative 1, that means the sixth term is going to come down as a denominator, so it becomes negative 3 over 6 to the positive first power now, which is negative 1/2. So that's another y. So we have a picture of what's supposed to happen. Here it goes. If I let x equal 0, y is 3. There it is. If I let x equal negative 1, or I'm sorry, that was just a 1, I made a mistake. So if this is, let's see, yeah. If I let x equal 1, then y is going to be 3, 6, 9, 12, 15, 18. Way down here. Okay? That's 1 and negative 18 over here. And this one is 0 and negative 3 over there. And if I let x equal negative 1 the other way over here, the y is going to be 1/2. Right there. Okay? So that's going to be negative 1 and negative 1/2. And the asymptote is at 0. So it will look something, I didn't draw very nicely, but it will look something like this. Woohoo! Okay, now there is a shift. Now it's the inverse of the h, okay? So even though it's plus 2, we're actually telling this thing to go left 2, shift 2 to the left, and down 2. So from here, shift 2, 1, 2, and down 2, 1, 2. Here's a new coordinate. Also same thing, 1, 2, 1, 2. This one also, 1, 2, 1, 2. Okay, and this is the new asymptote. So negative 2 is the new asymptote. And it will look something like this.